All right, folks, let's get started. Welcome to the this month's Apache Sedona Community Office Hour. And as you guys already know, so we have a office hour on the first Tuesday each month. And usually in the office hour, we'll talk about the latest updates in the community and also the new features will be included in the new release. So let's get started. So first of all, at Euros, I'll quickly go through the background of Apache Sedona and what it is and what it can help with your data pipeline, so on and so forth. So Sedona, as you see here, is an open source cluster computing engine for processing large-scale geospatial data. And we have our website, sedona.apache.org, and our GitHub is under Apache Sedona repo. And we also have our Twitter account. Oh, by the way, I forgot to update this. We also have our LinkedIn account. So please follow us on LinkedIn and on Twitter to get the latest update from the community. Oftentimes we share the new release information and also some tips about how to use Sedona, so on and so forth. And the status of Apache Sedona. So Sedona is a project started in 2015, became mature in 2017, and joined Apache Software Foundation in 2020. And it has more than 10,000 corporate users. And right now, GitHub, it has 120 contributors. It has 1,800 stars on GitHub. And it have right now, I think it has over 1.5 million monthly downloads. And it has over 32 million total downloads. And it is also ranked among top 0.3% most downloaded packages on PyPI. So as you see, so many companies are using Sedona in production, including Amazon, Databricks, Allstate, Mercedes-Benz, Safegraph, T-Mobile. Many companies are using Sedona. And a quick overview about the Sedona system architecture. So as you see from the diagram on your right hand side, on top, Sedona have the spatial query processing layer. So this layer provides spatial SQL API to the user. It also provides Python API, Scala Java API, as well as the R binding. In this layer, we also provide distributed spatial query algorithms that actually will take your spatial query workload, your spatial SQL query, and automatically figure out the best query algorithm to execute this query and then distribute the query workload to the entire cluster to hundreds of machines. After the spatial query processing layer, so we also have this layer called distributed spatial dataset layer. So in this layer, we actually perform spatial partitioning, spatial indexing, and spatial data compression. So the spatial partitioning, essentially what it does is it actually partitions spatial data, the big spatial data set into small partitions and distribute them to the machines in the cluster. So the spatial data partitioning usually it does two things. It first partitions the spatial data in the Sedona cluster based on their spatial proximity, such that each partition so the nearby data stay in the same partition. On the other hand, the spatial data partitioning also try to maintain the load balance of the data set. That means it tries to make sure that each partition in the cluster has similar size, physical size, compared to other partitions in the cluster. So after the distributed spatial dataset layer, so Sedona can also run on top of a number of different engines. So it runs on top of Apache Spark for batch processing. It also runs on top of Apache Flink for streaming processing. It also runs on top of Snowflake for mostly batch processing. And by the way, if you guys use Snowflake, please feel free to go to the marketplace, Snowflake marketplace. So there is a plugin called Sedona Snow that actually incorporate the functions, ST functions we have in open source Sedona. But so far, Apache Spark, Sedona on Apache Spark has the most comprehensive spatial query algorithm, uh, spatial functions. So it has the most comprehensive support. All right. So if you're interested in using Sedona, so the easiest way to get started is to use Sedona Docker image. So Sedona Docker image is hosted on Docker Hub under the official Apache Software Foundation account. So you can find it on Docker Hub by searching Apache Sedona. You can easily run the Docker image within two commands. First, you need to pull the image, Docker pull Apache Sedona, and you give it a version name. And secondly, you can run this Docker image by providing the necessary command information. So essentially what it does is it will start a Docker image that has a Jupyter notebook, right? You can actually try Sedona's Spatial SQL API and Python API in the browser-based Jupyter notebook. So that's the easiest way to try Sedona. All right. So regarding the release cadence of Sedona, Sedona right now follows this 3-month release cadence. So we tend to make a new release every 3 months. And we made a couple release in this year. So we made a release 151 in January, and another release 152 in May. Actually, so the 152 version has a critical bug, so we quickly made another release. In this like after 2 days after the new release. So that is 153. And in the same month, we also made a major release 160, which is a Euro. So this contains lots of breaking changes. So that's why we made another like major release out of that. So, but now since we already made the 16, it has been like almost 3 months since we made the 160 release. So we are looking at a new release. We're looking at new release 161. So we plan to release 161 in about 10 days, right? So that will be a maintenance release, and it will contain most updates, including this release, are bug fixes, but there is a API breaking change, and I'll talk about that later. All right. Now let's talk about what's new in 161 in the new release. So first of all, so there will be a native GeoJSON reader and writer inside on the 161. And if you guys have been using open source Sedona for some time, you actually know you probably should have known that Sedona actually is able at the moment is able to read and write GeoJSON data, but the solution we have is very awkward. So it actually you need to use both the Sedona ST as GeoJSON, ST from GeoJSON together with Sedona's RDD API together. So technically, that means you cannot perform all operations in pure SQL environment. So in order to overcome that, so in this release, we introduce a native data frame and SQL-based GeoJSON reader and writer. So the user experience of this reader and writer is really good. And as you can see from here, so actually, all you need to do is that you can use Sedona.read and you put the format GeoJSON there, and it will be able to read multi-line GeoJSON. So this is an example. This is an example of the multi-line GeoJSON, and this is actually a very hard example actually. So this is, if you guys are familiar with GeoJSON, so GeoJSON has this, first it has a top layer called feature collection, as you can see here. And inside the feature collection, so like usually each GeoJSON file should have a single feature collection. And within the feature collection, you usually end up having hundreds of thousands of features, right? So each feature is actually a spatial object, and this feature could have properties. So those are usually considered as the columns or the properties of that geometry. So this one is actually a hard example. In particular, it is really challenging to achieve this in a distributed environment, because like this entire file is a single feature collection, right? And it is and the object itself across multiple lines of this txt. So GeoJSON is essentially a txt file. It is a multi-line file that across this entire txt file. So you can easily use the sedona.read.format to read this multi-line GeoJSON, and eventually the output will be like this. So it will be able to read the geometry column, and all the properties will actually initially will be nested into a column called the properties column, and you will be able to take out those properties and create additional columns, or like move them to the upper level, the top level of the table. And after you read and manipulate the geometry data in Sedona, you can also write this GeoJSON, write the data frame, Sedona data frame, back to a GeoJSON file if needed. So you can use df.write.format GeoJSON and save it to a path. And it is also worth noting that, so the GeoJSON writer can only write a single line GeoJSON. So what it means is that, so if the input, say the input is a feature collection, right, something like this, and so it is a multi-line GeoJSON, but when you write it will be actually all truncated to the same line. Also, you will not be losing any content, but it will be saved to the same line, to single line GeoJSON. So all of them will be like the line breakers will be actually removed, and they will be merged into a single line. All right, let's move on. Another important update in Sedona 161, so is the GeoParquet 1.1 covering column support. So the GeoParquet spec has been evolving really fast. As you guys already know, Sedona has added support of GeoParquet spec 1.0 long time ago. Sedona was the first distributed engine that introduced GeoParquet support, and that's why many people love it. And so like right now, most of the data providers who generate GeoParquet files, they are actually using Sedona to generate those GeoParquet files. For example, Overture Map Foundation is actually using Sedona to generate their GeoParquet files. So if you guys have been using Overture data, right? So all their data you see in production, they were generated by Apache Sedona. So, but that was the GeoParquet 1.0 spec. So in the past few community office hours, I mentioned that, so we are looking at supporting GeoParquet 1.0 spec. So in the 1.0 spec, there are a couple important updates. So I would say there are two major updates. So one major update is, so it introduced something called geo-array encoding. So in GeoParquet 1.0, the encoding is WKB, but in GeoParquet 1.1, so it introduced a new native encoding in addition to the WKB encoding called GeoArrow encoding. So this encoding actually trying to utilize the like trying to encode the geometry using the existing primitive data types in Parquet. So that way, a Parquet writer will be able to automatically calculate the bounding boxes for free for the geometry column. So that is one thing. Another thing is the covering column support. So essentially what it does is, so in addition, in a GeoParquet file, in addition to the geometry column, so you can also add an additional column called a covering column. So what it does is it adds a bounding box value, a simplified bounding box value to each geometry in the table. So like essentially in each row of GeoParquet, you will have a geometry value and a covering value. Right now, the allowed covering value is B box. So the reason why uh, the spec adds a covering column is simply to enable vanilla plain Parquet reader to still be able to perform filter pushdown on the covering column. So as you probably know before, in GeoParquet 1.0 spec, so the filter pushdown is possible for sure, but because the bounding box information is only available at the file level. So that means it is not at the row group level. It is not at the page level. So that means so the reader has to be able to comprehend the bbox information in the file header, then perform filter pushdown. And that is not this kind of function is usually not available in a plain Parquet reader. So that's why in the GeoParquet spec, it tries to add a covering column. So as you can see, the covering column is basically using the primitive type. It's like four integers. Sorry, for double type values to describe the bounding box. So you can use very ordinary predicate in the filter in the var clause to filter out data. So here is an example. So this spatial query is actually I should have put this in the var clause, but you know what I mean here. So basically in the var clause, you can simply use two conditions, two predicates to filter out the spatial region, and usually the Parquet reader will be able to push down to do filter push down on this ordinary predicates. So that's basically the idea. So in Sedona, you will be able to specify first. You will be able to create a covering column, like this. Right? You can use st x mean, xt y mean, so on and so forth on the geometry column, and you can create a, a struct column called covering, and then we'll have the writer in the GeoParquet writer in Sedona GeoParquet writer. You specify the covering column name. So in this case, it is called bbox, and it will save the data to a particular location. Eventually, so the generated GeoParquet file will have the covering column. We'll have the covering column name in the metadata, and you'll also be able to perform the filtering on the covering column. And an important update which is related to the GeoParquet spec, is that so the Sedona community is actually right now working with the Parquet community, trying to add the native geometry type into Parquet as well as iceberg. So this proposal this proposal is to for the Parquet geometry one, it tries to add this geometry type by absorbing the GeoParquet spec. So that way, once that is accepted, so Parquet will have a native geometry type, and so the reader and writer of Parquet, if they want, they will be able to support the geometry type column, and that will actually increase the adoption of the geometry type data. Right now, GeoParquet, as you know, is a community standard. It is a standard that that is actually different from the original Parquet reader, and you need to have a dedicated GeoParquet reader and writer to enable, like, in order to fully utilize the utilize the benefits of GeoParquet. On the other hand, we're also working on bringing the geometry type to Apache Iceberg. So Apache Iceberg, if you guys know, is a very popular table format for the lakehouse architecture. So it does not have a geometry type either. We plan to first add the geometry type to Parquet and then move on to add that to Iceberg, because Iceberg internally relies on the Parquet file format to store the actual data of Iceberg. All right, what's next? So in Sedona 160, so we also added over 50 new ST functions. So if you I will click into this link later on to show you the functions we have in Sedona. But at the moment, Sedona for ST vector geometry functions, Sedona has over 190 functions, and for raster functions, the RS functions, Sedona has over 90 functions. So those are lots of functions, and Sedona now has the most spatial function compared to any other cloud data warehouse vendors. So if you want to have most comprehensive support for spatial, just go ahead and use Sedona. You will get what you want, and the Sedona community is really excited about this, and we are willing to add more functions, more ST functions and raster functions based on the requests from the community, right? Cool. All right. Another interesting update in Sedona 161. So the improvement of ST unit aggregate function in terms of performance. So initially, when we added the ST unit aggregate function, so we actually were not aware of the importance of this function, and were not even realize that there will be so many users using this function. So first of all, so what ST unit aggregate function does is, so first of all, it is an aggregate function. So if you are familiar with aggregator or aggregate function in general, so what it does is you give it a table, like an entire column. It will generate a single value or a handful number of values. So for example, so let's take some example, count, right? So count is an aggregate function. You give it the entire column and count the number of values in this column, like average, mean, max. So those are also aggregate functions. So you can also apply the aggregate function in group by. You can have a group by operator. You can have group by operator on the data on the column, and then apply an aggregated function on that column. So in Sedona, we also have a number of spatial aggregation functions. So we have ST envelope aggregate AGGR. We also have ST unit AGGR. So coming back to the ST unit AGGR. So this function is an aggregate function. So what it does is it takes the entire column. So assuming this column has bunch of polygons, right? So what it does is it actually uniting all these polygons all together. So suppose you have a, a bunch of polygons of your country, of the countries in the world, right? So essentially, what this function gives you is a few polygons. It gives you a multi-polygon object. In this multi-polygon object, it has several polygons. Each polygon will be the shape of each continent. So as you see here, so this aggregate function actually merge all the polygons that are next to each other, that touch each other, merge them together to a bigger polygon, right? This is called union operation, right? So essentially, it will try to unite all polygons together into a single polygon. But in the case there are polygons, you can never merge them together. If the polygons are totally disjoint. So in that case, it will output a multi-polygon that includes those disjointed polygons. So turns out over the years, we receive a lot of feedback from the community. It turns out this function is a really important function. Many people are using it, and the performance we had before was suboptimal. So in this release, we made a significant change to this ST-union aggregation function. So we first switched to the GTS NG robust union function that actually will speed up the one-on-one aggregation between two polygons. On the other hand, even our aggregator, we also have a cache capability that actually has buffer area to avoid repeated computation of the geometry. So if you look at the new outcome, the table down there, you will see that the new ST-union aggregation function has significant performance improvement over the old ST-union functions. In particular, when it comes to when it comes to a huge number of polygons, right? So say you have 10,000 polygons in the table. So the new ST-union functions is about two orders of magnitude faster than the old ST-union function. So as you see here, so this is significant performance improvement. And I believe the community will enjoy it and will love the new performance. All right. Another important bug fix in Sedona 161 is we make sure ST function return geometries with correct SRD. So the SRD information is something we didn't pay enough attention to in the past. So what happened in the Sedona functions is some of the ST functions preserves SRDs of the input geometries, and some of them do not, which in that case they are supposed when they are supposed to preserve SRD, right? So this will lead to situation that your input has SRD, right? But the output after a number of operations in Sedona, so the output will lose the SRD information. So in this release, we try to fix this issue. Essentially, for any geometry manipulation functions, the SRD of the output geometry should be the same as input geometry. So this includes many functions. For example, ST buffer, for example, STX, X mean, ST centroid, ST point. So any function that create a new geometry based on the input geometry, you will need to preserve the SRD. And for ST transform, which is another very popular functions, the ST transform needs to the SRD out output geometry is actually the target size, different from the input geometry. So this is an important bug fix in 161. And there is an API breaking change in Sedona 161 as well. So this is actually about the raster functions, raster functionalities. So in the past, the following four raster functions are as metadata, are as geotransform, zonal stats, summary stats. So this function returns return in the output it return array, an array of values. So this because this function by design are supposed to return multiple values. But the problem of returning an array data type is so you don't know what the schema of that array, right? You don't know schema of that array. It makes it extremely hard for the user to understand the meaning of each value. So that's why in this release, we are actually changing the output auto schema of these four functions. So essentially, instead of returning an array, so they return uh, a struct, a struct of columns, a struct of columns. So that means if you print the schema of that output, it will actually tell you the meaning, the name of each field, the meaning of each field. So you will know so what this value represents. You no longer need to go back to the documentation website and look for the meaning of each value in this array. So this is the API breaking change. For example, the RS metadata is a function that actually returns returns all the metadata in the raster functions, including the resolution, width, height, SRID, this kind of information. So it has lots of metadata information. So it will be really helpful if we generate that in a struct type that has a schema information. All right. So that's about the upcoming release, Sedona 161. And that will be out in about 10 days. And it will go through a voting process. Now I'm going to talk about so what we plan to have in the next few release, not just one release, in the next few release. In particular, for example, Sedona 170, 170. So 170 will be a major release. And what we plan to do is that we plan to add something called distributed kin join, distributed kin nearest neighbor join. So a kin join, if you guys don't know what kin is, first of all, kin in short, a kin like represent kin nearest neighbor query, right? So essentially, so given an object or given a point, so it tries to find the kin nearest neighbor around this object. Say I want to find the top 20 nearest restaurants, right? So similarly, KNN join is another operator that actually is a join operator, but for the KNN. So it involves two data sets. So for each record in the first data set, it finds the k nearest neighbors from the second data set based on a given distance metric. So for example, this will be like, so we have a bunch of customers. We want to find the top 20 restaurant for each of the customers, right? So you have another case could be you have multiple real estate properties. You want to find top top five, the closest public school for each of the real estate properties. So those are very interesting use cases, real world use cases for distributed kin join. So we plan to introduce an operator called STKN. So this operator is very interesting. First of all, in standard spatial SQL, there is a spatial SQL standard has been out there for a while. So spatial SQL standard does not have this operator STKN, right? And so we have to create something creative our own. On the other hand, so the syntax or the behavior of can join is not something that is natively available or can be easily expressed in a SQL syntax. So essentially, what happens is, so we will have to actually change the query plan. So essentially, like if you look at the query example here, right, STKN syntax here. So if you just implement STKN as an expression, so this is not telling you this is going to be doing a join and on with a KN behavior. So what happens behind the scene is we actually change the query plan of this SQL query, and we change the query plan and added our own query algorithm. So we will be releasing this STKN instead of 170, which is in a few months, and our users in the community are welcome to try this out. Another important thing we will add in the next few release is we will add more native spatial data source like reader and writer for spatial data formats. So that includes shapefile, flat GeoBuff, and GeoParquet. So shapefile reader has, if you guys use Sedona before, shapefile reader in Sedona has been there for years, and but it has some issues, some minor issues. It is usually first because it was when the shapefile reader was implemented, we did not have the data frame based or SQL based reader. So the reader we had, it was built on top of the RDD API. So it is a bit out of date. And secondly, it does not preserve the data type in the shapefile, right? So it preserved the column name, but it somehow didn't preserve the column type. So we plan to fix these minor issues by introducing more native shapefile reader built on top of the data frame SQL API. Okay, so this is about the new features. And as usual, so Sedona is always call for help. So as a member of the community, you are welcome to participate in the development of Sedona project. So you can contribute to Sedona not only by contribute to some important functions. You can actually contribute to Sedona by making changes to a document, making changes to the examples, right? So and also participate in the vote process of each Sedona release, right? So all of this will be really helpful to the community, and it does not take you lots of time, but it will be a great help to the community if we have more people helping us. That will prevent us from like creating bugs in the release. All right. So I think that's all for the for this community office hour. So the next phase of this office hour will be, so let's enter the Q&A session, right? And see if you have any questions you want to ask the maintainer of Apache Sedona. And let's start with people in the uh in the all the participants. So I will call the name here on the list. Dennis,
Hey,
do you want to introduce yourself?
hey, good morning. I'm Dennis Weatherall. I can put my camera on, I don't know. But I'm just getting familiar with the Apache Sedona environment. I liked hearing about the changes you're making. And it's I'm going to definitely pull down that Docker image and start using it. I've got a I've got some experience with Docker images, so that sounds like a good thing.
Sounds great. Yeah, please feel free to reach out to us. And like we also have a Discord channel, Discord server.
Oh,
Right?
okay.
Yeah, so you can let me uh
Is and I liked your suggestion on how to get involved with bug testing. I might give that a try. Might be a good way to get my feet wet.
yeah, thank you. That will be really helpful. So let me send you the link about the Sedona
Oh, thanks.
community. Oh,
Just added it.
cool. Yeah, thanks, Ben.
Thank you.
Yeah, you can join our Discord server and we like the core members of the community are out there, right? If you have any question, we are willing to help.
That's great. Do you have will these slides be available for because there was some great details on here. I would like to
Yeah,
review
all
these.
slides will be available for
Oh,
each
great.
community observer, and I believe the video is also available. So we usually
Excellent.
upload the videos to a YouTube channel. So we will
Thank you.
share, yeah, we'll share with you. So we'll post it on our LinkedIn account and Twitter account. So you'll
Mhm.
be able to find it. Find it.
I don't know how many other people are on the call. I don't want to take up too much time with basic questions, but if there aren't, I wouldn't mind asking a couple of questions about this some of this SQL statements you had.
Yeah, please go ahead. Please go ahead.
Sure. So of course, I have experience reading SQL. So when you have a table in those from clauses, for example, I think there was one that was table R and table S, and so would that typically be? And I think you gave the example of KNN,
Mm-hmm.
next neighbor. So in practice, what would typically populate those tables? Would that be like, for example, one table might represent a county, or would it be truly like a square on a map? I'm just trying to visualize what a table represents in GeoSQL. Forgive the very basic question.
Yeah, no
Um,
problem, no problem. So yeah, so in spatial SQL, first of all, it like in any kind of relational databases, you need to have
mhm.
the thing called data type, right?
Okay. Yeah.
So in spatial SQL, we have this thing called geometry type. So geometry data type. So in the
Hmm.
geometry data type, geometry data type, first of all, it is a parent data type, right?
Hmm.
So it is generic geometry data type. That means in the same column, in the data that has geometry type, you can actually store multiple different type of geometries. You can save point, you can save polygons, you can save length strings, right? So length strings
Okay.
is like the trajectories, trajectories of vehicles. So in the same table, you can save like in the same column of that table, you can save a bunch of polygons or point or whatever geometry shape you want to save, right? So once that is in place, you can run spatial queries, SQL
Hmm.
queries on top of that. So imagine you can imagine this table, like you can put this table on a map, right?
Yeah.
So each geometry, each record, each row in this table is a geometry. It could be a polygon, like buildings or counties, like the boundaries
Right.
of the object. It could
Hmm.
be also a point of interest, like just longitude latitude is a point. It could be also the
The
trajectories.
trajectory. Gotcha.
Yes,
That is, so it's a very rich object that could represent varying degrees of complexity from a point to a trajectory to a region. Or
exactly.
gotcha. Okay.
Yeah,
Thank you.
no problem. Uh, all right. So I okay. So I saw someone raise a hand. Look, uh,
Hi, Jen. I've just got a quick question. I've been trying to do some raster operations in Sedona recently, and they were relatively straightforward to do with like raster IO in Python or NumPy. But because they're quite high resolution rasters, uh, I ended up running into a lot of problems with like running out of memory and things like that. I'm just wondering if those sort of problems aren't something Sedona's optimized for. In the end, I was able to do it using RS tile explode, but I couldn't do it using something like RS map algebra in the end. And I'm just wondering if that's a sort of an area that it's currently not optimized for.
Yeah, so you're right. So if there are big geometries, sorry, big rasters, right? Like raster with like 10,000 by 10,000 resolution. So Sedona won't be able to manipulate that directly because this entire raster image will explode memory. So you will have to apply the RS tile explode to chop the images to smaller tiles. Like this is I guess it is relatively common relatively common operations in the raster data manipulation. So you need to explicitly chop that to smaller raster tiles and distribute that to the cluster. And if you still cannot pass the map algebra, so you could try to like chop the image to even smaller tiles. So that will actually reduce the memory overhead of the of the cluster. And regarding that, we can also send you some information about how to optimize the raster big raster operation. So
Yeah, that'd be great. Thank you. I like I said, I did manage to get it to work with RS Tile Explode, but I'm also thinking of whether I could use Sedona for an optimization problem that's quite complex, and you need all of the information in the raster to be processed it at once. So it might become challenging for that.
Yeah, totally understand. So we will reach out to you after the call, right? So and share some materials with you to make sure
Yeah, that'd be great. Thank you.
help you optimize the workflow. Cool. Yeah, I also saw a question from Spencer. Spencer, do you want to speak?
Sure can. Yeah, I'm also pretty new to Sedona. Haven't yet been able to play around with the packages at all, but have some experience with other geospatial packages and things like that. One of the biggest things that I've ran into is some functions work specifically for geography and some work for geometry. How's Sedona set up in that sense? Are most functions available to both? Can Sedona handle geometry at all?
Yeah, that's a really good question. So right now, Sedona only has one data type called geometry data type, right? So by default, all operations only operate on geometry type, not geography type. But some functions, some important function in Sedona, we actually offer the geography support. Like we offer something called spheroid mode that actually will kind of achieve the output of the geography. So for example, we'll do ST distance on Sedona. So we have something called ST distance sphere and ST distance spheroid. So those functions actually will calculate the grid circle distance and the vicinity algorithm of the distance between two geometries. That is kind of like the spherical geography distance between geometries. And there is also ST area sphere and ST length sphere. So those functions also work with the geometry data, but with the spherical objects. Yeah.
Great.
Yeah,
Cool.
but we are actually will support geography type natively very soon. So later this year or earlier next year. Yeah.
Sounds great. Great to follow along. Thanks, guys.
Yeah, thank you. Uh, all right. So I think we have answered all questions. So uh, let's do a quick roundtable introduction about from the Sedona maintainers. So Christine, Furkan, and Pranam. So those they are Sedona community members and Sedona PMC committers. So yeah, so let's do a roundtable introduction. So Christine, do you want to introduce yourself?
Yeah, sure. I'm Christine. I've been working on the Apache Sedona code base for more than 2 years, and now I'm a PMC member of Apache Sedona, and currently I'm working on some of the new features of Apache Sedona, and including some of the features that will be included in the next release. For example, the GeoParquet enhancements, and so on. And yeah, so that's it. And if you have any questions, you can reach out to the maintainers on Discord or submit GitHub issues.
Thank you, Christine. Furkan, please.
Hi everyone, I'm Furkan and I've been committing to Sedona for about a year, and I've contributed a lot to the SC functions and some of the raster functions. And yeah, it's nice to be here. Thank you, Jim.
Thank you, Furkan. Pranam.
Hi, folks. My name is Pranav. I've been committing to Sedona for a year too. And yeah, I've been committing to mostly raster functions and also some ST functions. So great to hear the discussion over here. Let us know if you have any special interests in any of the new functions. Thanks.
All right. Thanks everybody for attending the office hour today. And as I mentioned, the slides will be available and the video will be available too. Very happy to meet you guys today. And I think that's it for today. And have a nice day, folks.
Thanks.
Thank you, guys.
Bye-bye.
Bye.